Hi everyone, good afternoon. In this lecture series, we are going to see the topic in rectifiers. These are the contents we are going to see in this lecture series. Introduction, half wave rectifier, working principle, full wave rectifier, applications, conclusion. So before entering into the topic, the first thing we have to know what we mean by a rectifier. Rectification is a method to convert the alternating current to the direct current. So it includes both the full wave rectification as well as the half wave rectification. In both the cases, how the rectification is formed means by utilizing the characteristics that the current flows only in the positive direction in a diode. So this is termed to be as the rectification. There are two types of rectifiers. One is half wave rectifier, another one will be the full wave rectifier. In half wave rectifier, suppose the supply is applied to the input, a positive cycle will appear across the load and the negative half cycle will be suppressed. So this can be done by using the semiconductor PN junction diode. Suppose if the diode is forward bias, it gives little resistance, and when it is reversed bias, it provides high resistance. So this is the diagram this is the circuit diagram for half wave rectifier. Here we are connecting the supply, that is transformer. We are having the diode, and across the diode we have connected the resistance as RL, that is load resistant. So here suppose when the supply is given, so during the positive half cycle the diode will conduct, but during the negative half cycle the diode will not conduct, it is suppressed. So this is the waveform, what is the input signal we are applying. So only during the positive half cycle the waveform is there, during the negative half cycle it will get suppressed. Full wave rectifier. So what do you mean by full wave rectifier means? It is defined as the rectifier that converts the complete cycle of the alternating current into pulsating DC. So here in a half wave rectifier we used only one diode, but in case of the full wave rectifier we are using two diodes. So what is the main advantage of the full wave rectifier over the half wave rectifier is the average output voltage is higher in full wave rectifier. So there will be less ripple produced in the full wave rectifier when compared to that of the half wave rectifier. So this is the circuit diagram of the full wave rectifier. So here we are having the diodes, we are having two diodes, that is D1 and D2, and here we are going to see the charging and discharging conditions of the rectifiers, so that we are having the output waveform of the half wave as well as full wave. So here when connected to that of the capacitor, the charging may occur. So here the discharging will occur in the below output. So here we are going to see the full wave rectifier operation, and at the same time, so here we are connecting the two diodes, that is we are having D1 as well as D2, and this is the output waveform of the full wave rectifier. Suppose we are applying the positive half cycle during the current flow, diode D1 conducts, during the negative half cycle D2 conducts. At that time during the positive half cycle only positive half of the wave will appear, but during the negative half cycle the negative wave will appear. So this is the we are going to combine both the positive and negative. So this is the output obtained. So this is the combined output we are getting. So applications of rectifier. So where we are using this application, for example, if we go for the power supply, we are using for the electronic devices, the battery gets charging, so we are using in the motor drives, welding application. In UPS we are connecting. So and we are having the power transmission. So these are all the applications of the rectifiers. So in conclusion, what we are going to say means the rectifiers can be used in the model electrical and electronic system, and the fundamental of the operation of the devices from the household electronics to industrial machinery we are using in the power system. Whether we are used in the power supplies, there will be a battery charging, motor control, or the communication systems. The rectifiers ensure a stable and there will be a DC output. So these are all the assessment questions. Thank you.